Hello everyone, good evening. Good evening. How we are doing today? I hope we had a wonderful day. So today we are going to be talking about the basics of computer networks. So let's get to it. So our objective is to introduce the concept of computer networks and their benefits. We're going to discuss different types of computer network and their uses, and then we'll talk about the basic components of a computer network. Alright, so what is a computer network? I'm sure you guys have heard about computer networks or networks once in a while, but let's just break it down. So a computer network is a group of computers and gadgets linked together to communicate, share resources, and exchange information. So let's say for example in the class we have like 5 students and we want each like all the 5 laptops, each of the 5 students have their laptops. We want the 5 laptops to communicate with one another so that I can be able to send information. I want to send a file from laptop A to laptop D. You understand? So connecting those 5 laptops together is called a computer network. So it can be wired or wireless. So let's say for example now in your house you have like your phones, you have your laptop and you want to communicate between your phone and your laptop. If you use a USB cord, that is a computer network, that is using wired means of communication. Then if you have a Wi-Fi in your home and everybody in your house connects to your Wi-Fi, right, that is a wireless computer network. So it may include various hardware components such as routers, switches, access points, so on and so forth. All right. So what are the benefits of computer networks? Number one, we have resource sharing. So let's say for example somebody downloaded a nice movie and you want to watch the movie. Rather than going to download it by yourself, you can just tell the person, oh, share it to me. The person can airdrop it for you. The person can use a Bluetooth to send this. The person can use a cord. So maybe here it's on the laptop and you want to send it to your phone. You can use a USB cord to connect to get and share that movie. So it one of the benefits of computer networks is for you to be able to share resources. So for example now like in an office, rather than everybody buying a printer, let's say every desk would have a printer. We can just have one printer in the office and then everybody can connect to that printer, and when you want to print you can send the file you want to print to the printer and then you can print out your document without everybody having to buy a printer and put it beside their laptop. Then we have servers, so things like database servers, the web servers, right? Everybody can be able to share and make use of this resource. So resource sharing saves money and improves efficiency rather. So rather than buying these things with money, you can just buy one or two and everyone can be able to share. Then number two is communication. Computer networks allow users to communicate with each other via email. You send mail to one another by instant messaging, things like WhatsApp, IG, Twitter, then via video conferencing. I remember during the COVID period, almost everybody was using Google Meet, Zoom, all those video conferencing applications here. So because of computer network, what made that possible was networking, computer networking. So this improves communication and collaboration. You see, you don't have to be in the same physical location to communicate with someone, but with computer networking, you can be able to share the information that you want to tell the person via either email, via your messaging applications, or via video conferencing. All right, so we have access to information. So computer network gives us the ability to access information from anywhere in the world. Like there is literally no topic that you want to search about or no topic that you want to do research about that you won't find on the internet. all the time. Like in fact, everything on YouTube, on Twitter, on Google, you can find information. So, and this is possible because of computer network. You understand? So, the internet is an example of computer network. The internet is just a connection of many different computer connections. You understand? So with computer network, we can have access to information, which is a vast okay, this includes access to the internet, which is a vast source of information and resources. Yes, the internet has a lot of information. Then we have remote access. So I remember during the COVID period, a lot of people were able to work remotely, and people still do work remotely. Why is that? It's computer networking. So computer network allows like co-workers or allow colleagues to be able to access strictly confidential information of the company from anywhere in the world. Do you get? So with computer network, you can be in Zamfara and be able to access um everything that you need to work with a company in Lagos. You get? So that is the beauty and the wonderfulness of computer networks. So the next thing we go to centralized management. So another very important thing about computer networking is that you can have a centralized way of managing resources and security and updates. So let's say for example now all your in an organization, all your laptops are connected to a network, right? And they are all Windows systems. And Windows brings up an update rather than making everybody to go one by one and do that update. You can just run the update across all the systems. As long as they're connected to the computer network, you can send the update across all the systems on that network, and then all they need to do is just restart their system and the update will install. You get? So even in terms of security, when you connect different computers together, you can have a centralized way of managing what goes in and comes out of the network. That's security. You understand? And managing the resources, who has access to what. Okay, we'll say the guests can only have access to this website. If you're a co-worker, you can have access to this particular resource. If you are not in the financial team, you don't need to have access to the financial team's network. You understand? So with computer networking, you can be able to um segregate different resources, segregate different things for different access level. I remember the last time in the class we are talking about privilege, the least privilege principle, the principle of least privilege, whereby if someone doesn't need that permission, you make sure that they don't have that permission. And this is possible via network, computer network. When you have a centralized way of managing these things, you don't have to do everything one by one. So we had data backup and recovery. So data can be backed up and recovered efficiently across networks. Then we have the different types of computer networks. So number one, we have the local area network that is usually called the LAN. So LAN typically covers a small geographical area such as a single building, an office, a campus. So LAN is usually like the smallest form of computer network. So let's say for example, everybody in a class is connected together, their laptops or their systems are connected together. That's an example of a LAN. Or let's say in your house now, everybody in your house, your mom, your dad, your brothers, your sisters are all connected to your Wi-Fi. That is a LAN. You understand? So LAN are used for local data sharing, resource sharing, connecting device within a confined area. So basically, LAN is more of like a smaller form of computer networking. So it has to do with a small geographical area, a small office building, your home networks, just small. Basically, that's what if you want to know anything about LAN, that's local area network. Just know that it's for a small geographical location. Know that. Then for the MAN, which is called Metropolitan Area Network, it covers a larger geographical area than LAN, but is limited to a city or metropolitan region. So what this means is that, let's say for example now, um you have an office, let's say you have which bank, you have like a bank, and your bank have different locations in Lagos now, for example. So a land would mean, sorry, a man rather, a man would mean, let's say you have let's say 5 branches in Lagos: branch A, branch B, branch C, branch D, branch E, right? Branch A is connected via a LAN, branch B is connected via a LAN, branch C is connected by a LAN, branch D LAN, and branch E LAN. So when you connect those 5 together, that's a MAN. So you are connecting, it's just based on Lagos location. Understand? So MAN is restricted to just a city or a location. In fact, sometimes a MAN can be maybe only Ajah. Let's say for example in Lagos there's a place called Ajah, just only that region Ajah. If you are connecting devices in that region, that is a MAN. You understand? So MAN facilitates data sharing and connectivity between multiple LANs within a city, like I explained, multiple LANs within a city. So if let's say the 5 branches are connected via LAN, when you connect those 5 branches together, as long as it's just in Lagos, that is a LAN. That is a MAN rather, that is a MAN. So an example of this is citywide Wi-Fi networks, university campus. Exactly. For university campus, right, you have different departments. You have your sociology department, you have the engineering department, you have the development and leadership department, you have the hostels, right? You have the hostels, and the hostel will have like network connection. You have the cafeteria, it has network connection. So when you are connecting all those things together, that is a MAN. You understand? That is a metropolitan area network. So it is larger than a LAN, but it's still limited to a city or a region. You understand? It's still limited to a city or a region. So we go to the next one. So which is the wide area network. So for the wide area network, this one is now larger than the LAN and the MAN. So a one that is wide area network spans large geographical areas, countries, or even continents. So a MAN connects multiple LANs and MANs over a long distance and enable global communication and data exchange. So one of the major example of a one which is wide area network. I feel like I have to be saying the full one because all the landman one I feel like it's confusing. So let's go. So the wide area network, a very good example of this is the internet. So basically the internet is a connection of different local area network and metropolitan area network. So remember we explained what the LAN is. The LAN is smaller geographical location, like in a classroom, a branch of an office. You understand? And MAN is when you are connecting different LANs together. Or when you are connecting the local area network and the metropolitan area network all together, that is your wide area network. So let's use the example of the office that we have. Let's say we have a bank now and we have 5 branches in Lagos, we have 5 branches in Abuja, we have 5 branches in Port Harcourt, we have 5 branches in Anambra, we have 5 branches in Akwa Ibom, right? If we are connecting all of them together now, we want that if you are in Lagos office, you can talk to the person in Akwa Ibom. You can send a message like through the normal office protocols. Send the message to the person, maybe through Teams or something. You understand? So to be able to do that, we want to connect the Lagos office, the Abuja office, the Port Harcourt office, the Anambra office, the Akwa Ibom office. We want to connect all these offices together. When we are doing that connection, that is a wide area network. It seems like the internet. The internet spans across continents. You from where you are in Nigeria, you can talk to someone in the US, you can talk to someone in Canada, you can talk to someone in Korea, you can literally talk to anyone in Australia. So the internet is a typical example of a wide area network because it spans across a large geographical areas rather, and it span across countries, it span across continents. So we have another example, global corporate network. Yes, for example now, if you have a branch of that your bank abroad as well, and they can be able to communicate with people in Nigeria through the normal office network, then that is a wide area network as well. Then we have intercontinental data links. So basically, just know that a LAN is the smallest unit. That's what local area network now. Let me say the whole one. Local area network is a smaller unit, the smallest unit. Metropolitan area network is the one after local area network. It's a combination or it's a connection of different local area networks. Then while the wide area network is a combination or the connection of multiple local area networks and multiple metropolitan area network. So just know is basically the difference is the sizes. So when you are thinking about the difference, just know that the difference is size. You think about oh difference is size. I think that way it will be easier to get and understand. So we have the wireless LAN. So the wireless LAN, which is the wireless local area network, it is similar to local area network but wireless for connection, which is using the Wi-Fi technology. So um wireless local area network provides mobility and flexibility within a confined area, allowing users to connect without physical connection and cable. So let's say for example your house now, you set up your Wi-Fi, maybe you're using something like Spectranet, you're using something like an MTN router, or you bought a Airtel router. You should have bought one of these internet service routers, right? You buy it, you keep it in your house, you set it up, you put password, put name and password that everybody in your house, right, can connect. Your brother, your auntie, your mom, your siblings, all of them can connect. That is a wireless local area network because you don't have to be connected through cable. Cables we're talking about are things like Ethernet cable now. You have to be connected through cable, right? But everybody in the house can make use of that Wi-Fi. You understand? Then we have public Wi-Fi. Let's say in the cafeteria now. I think that there are some cafeterias that have free Wi-Fi's. Very importantly, disclaimer and announcement. Please do not connect to free Wi-Fi's. I mean, I understand it's juicy, it's nice, you want to use somebody's data, but most times, right, very importantly, most times these Wi-Fi's are they are sometimes set up by intruders. Number one, they're sometimes set up by bad people, by attackers because they want to create something called a honeypot. So a honeypot is something that looks very juicy and everybody wants to like access it, you understand? Why it's actually what they want to use to take information. And number two is that sometimes an attacker can be listening to a public Wi-Fi communications that happen in a public Wi-Fi. So if you connect to the public Wi-Fi and you're trying to do like a transfer or something, the information that or the things you might be doing on that Wi-Fi might not be encrypted. You understand? And an attacker can be able to listen or see things you are doing, more of like listen to things that you are doing and then plan an attack for you. Another thing we have airport network. So some places when you go to the airport you see free Wi-Fi, again do not connect. I feel like I want to say this like 17 times. Please do not connect. I'm very serious about it. Don't connect to free Wi-Fi's. I know it's very tempting, but don't connect because sometimes you don't know who is behind the free Wi-Fi. I don't know whether I told you guys about one of my friends or my friend's friend. So I got to hear about it that they wanted to test something. They went to an area in Lagos that they do free Wi-Fi stuff. Like there's always free Wi-Fi around that area in Lagos, and they named it exactly the same thing, set it up, and people were connecting. You understand? So so I'm just saying it again, please don't connect to free Wi-Fi. So that's an example of a wireless local area network. Then we have our virtual private network, which is the VPN. This VPN, I'm sure you guys have heard of VPN. That time when they blocked Twitter for Nigeria, everybody was connecting over VPN. Everybody was connecting over VPN. But yeah, this VPN is very important. I say this VPN is like a very important thing to note about computer network and when you are coming in the line of cybersecurity. So one of your assignments would be to research more about VPNs and to understand how VPN work. It is very important to have that understanding because a lot of times when people are working remotely, they connect via VPNs, right? So it's a very important thing to understand. So we have the VPN. So it can be a local area network, a metropolitan area network, or a wild area network. It can be any of them. It doesn't have to be one, you understand? But the goal is to create secure and encrypted connection over public network. So what happens is that there is a tunnel. A tunnel is created by which the user, let's say for example, a co-worker now wants to access the corporate environment like the office network, and the person is at home. So the person can connect via VPN to the office network, you understand, and that connection is going to be a secured and encrypted connection, you understand. So because you're not going to be on the company's network, you're using your own personal network, but you're trying to connect into the company's network. So that way of communication has to be over a secured and encrypted tunnel. So the purpose of VPN is to ensure data privacy and security and allow remote users to access resources as if they were on the private network. So how this works is that let's say you are home right now, you are working remotely and you want to make use of the equipment or the resources or the software that is only available on the company's network. Let's say for example they installed something, let's say a software for one of the accounting softwares, and you can only make use of it when you are connected to the company's network. For you to be able to make use of that accounting software, you need to connect via VPN. You understand? So this VPN is very important because lots of corporate organizations make use of VPN. In fact, if you're a corporate organization and you are doing remote work, you will have to be using VPN because if you're not using VPN, or here is your case. So secure browsing for individuals. So this was the time when people were using VPN to do Twitter and the rest. But you have to be careful because there are different VPN softwares out there, VPN applications out there. There are a lot of them, right? You have to be careful of the ones you are picking. Make sure that it's the right one, is from a reliable source. You understand? And most times these VPN applications are expensive. Like not expensive, but like you have to pay for them. So let's go next. So we are talking about the components of computer networks. So computer network can be categorized into two. We have the hardware and the software. Right, so let's go to node. So nodes are devices that are connected to the networks, such as we have the computer, the printer, the servers, etc. So what exactly is a node? So let's think about the computer network. Now let's use a classroom. Now let's say in the classroom there is a teacher and 22 students, and all the 22 students want to be connected to each other plus the teacher. There's a printer in the class, there is a router, they can use wired connection or they can use Wi-Fi. So either way, either one of them, the student can make use of it. So the endpoints, so we have two types of nodes, right? The end devices are the devices that are used by users to access the network. So things like your computer, your smartphone, that's your phone that you have, your tablets, right? Your printer, you get, those are called end devices. Why are they end devices? Because they are using it at the end of the network. That basically, yeah, this normal English. I think at the end, like this is the last place that's when you are doing your connection, that's the last point of your connection. Basically, it's what you are using to access the internet. So, for example, you need to connect your laptop to the internet and connect your laptop to access the network. So that is why it's an end device. Your phone is an end device. Your laptop is an end device. The desktop is an end device. Your tablet is an end device. Your printer is an end device. You understand? So that's an end device. While the intermediate devices are devices that are used to connect nodes together. Let's say, for example, now we have a switch or a hub, right? And you want to connect like 10 laptops per hub. So that hub right now is like intermediate device, because with that hub now you're not accessing internet, but you're using it to join different endpoints together. You understand? To access that network, you're using the hub to join it. Even when it comes to your routers, right? Your router is not the end device because you're not using the router to, and you have communicate directly with the router as an individual, right? So the router basically just helps your computers, your laptops, your endpoint devices to be able to communicate to the network. So that's why there are two types of node. We have the end devices and we have the intermediate devices. So the end devices are basically what you're using to access the internet. Sorry, not internet, the network. Or what you're using to access the network, while intermediate devices are used to connect the endpoints together. I hope it's clear enough. Should I say it again? Let me say it again. So the endpoints are devices that are used to access the networks, while the intermediate devices are used to connect the endpoints together. So let me read what is here. So the intermediate devices are devices that connect nodes together and provide routing and switching functionalities. Example of intermediate devices are, we have the routers, we have the switches, and we have the hubs. So links now. So first of all, we talked about node. The next thing is links. So as the name implies, link, you're linking something together. So these are physical connections between the nodes. So how do we want to connect the nodes together? How do we want, let's say we have a switch now. How do we want to connect different computers, different devices to that switch? That how is what the link answers. What the link answers. So how do we want to connect this thing together? We can either use a wired link or a wireless link. You understand? So a wired link are cables to connect the nodes together. So an example of a cable is your Ethernet cable. I don't know if you guys have seen Ethernet cable before, but it's usually used to for internet connection. Excuse me. It's usually used for internet connection, or you have your coaxial cables. While the wireless make use of radio waves to connect nodes together. So things like your Wi-Fi, your Bluetooth, those are wireless links. So again, links answer the question how. So let's say you have devices together, you have a lot of devices. I want to connect them together as a network. How will you do it? That is what the link answers. So link answers the question of how. So you can either use wired links, things like Ethernet cable, coaxial cable, or you can use wireless, things like Wi-Fi, like when you're using your internet providers, routers, or you want to make use of Bluetooth. I mean, almost every devices have Bluetooth and Wi-Fi enabled. So you pick the one that makes sense, that works best for you. The next thing we have the network interface card. This network interface card is important. Every device that wants to connect to the internet must have this. And so if you don't have this, you can't connect to the internet. Even on your laptop, if you open your laptop, you will see it there. It's inside. These are put in by the manufacturers. You understand? So the goal, the NICs are devices that allow nodes to connect to the network. NICs are installed in computers and other devices. So basically, as a device is being configured, as a device is being manufactured by the manufacturer, NIC and NIC card and an NIC is placed into the device. So this one is a laptop NIC. What is shown on this picture is a laptop NIC, but there are smaller ones for phones. There are smaller ones for other devices. You understand? So if a laptop, if a phone, if any device and endpoint does not have NIC, that device will have difficulty connecting to a network. But then there are also external network interface cards. So they are the ones where you can plug. So let's say for example now your internal NIC is bad. You can buy an external NIC and plug it to your device. That way you can be able to access network as well. So if you don't have it, it's not do or die, you can get an external one. But in fact, all devices have it on a normal day. So let's go to the next one. We have hubs. So what are hubs? Hubs are devices that are used to connect multiple nodes together. So we talked about what nodes are, right? Remember that nodes are the devices. So nodes are devices. So we have our endpoints and devices, which are things like your laptop, your router, no, your laptops, your printers, your computers, your smartphones. Those are endpoints. Those are endpoint devices or end devices, right? So for a hub now, what is the goal of the hub? The goal of the hub is to connect these endpoints together or connect like nodes together. So how do you do that? For example, let's say we have like 10 devices we want to connect. We can use from the picture that is here, you are using a wired connection to connect these hubs together. So a hub can connect to another hub, right? But also we can connect it to devices, your end device and your laptops and everything. Let's say for example, you have computer A, B, C, D, E, right? And you want to send from A to D. So what the hub will do is that if it receives the information from A, it will broadcast it to everybody, A, B, C, D, E, everybody, you understand? Rather B, C, D, E. And you now, that is in D, you know that the message is coming to you. Once you see that this is your address, you will now collect this message, that this is your own message. While the other people, B, C, and E now, they will drop the message because it's not for them. They are seeing that the address is not their own address. You understand? So that's how hub works. So let me explain it again. So how does hub work? Let me read then I'll explain. So hubs broadcast all data packets that are received to all the nodes that are connected to it. Let's say you have a hub now as seen in the image here now, and you connected 5 devices together. You have A, B, C, D, E. And you want to send a connection or A device A now wants to send an important information from A to E. One send from A to E now. So when A sends, first of all, A will send information to the hub, right? Then the hub will now broadcast the information to B, C, D, E. You understand? But remember that when you are sending information, whatever data that is being sent has the address of the person that is supposed to collect the information. So his address will be on that data, but the data is going to be sent to everybody. So if B, C, D sees that it's not their address, they will just drop the information, they'll drop the data. While when E sees that okay, this is my address, it will now receive the information. So that's how hubs work. But this method of communication can lead to network congestion. Just imagine you keep broadcasting everybody's message. You know, it's not for everybody, but you're broadcasting it to everybody. So it can lead to network congestion, especially in large networks. So we go over to switches. So switches are more intelligent than hub and can improve performance of a network. So switches can learn the MAC addresses of the devices that are connected to and forward data packets only to the destination device. When we talked about hub, we talk about how hub works, that hub will literally broadcast information to everybody. But for switches, they are different. So when a device is connected to a switch, the switch will learn the MAC address of a device. Remember, so we've not talked about MAC address and IP. Don't worry, we'll talk about it very soon. But MAC address are unique addresses assigned to a device. Those ones won't change. People can do MAC address spoofing, but those ones won't change. Normal way, in a normal world, right? MAC addresses are not meant to change. So when devices are connected to switch, the switch will learn the MAC address of that device, right? And so let's go back to our former example. We have A, B, C, D, E devices are connected, right? So device E wants to send data to device E. What will happen is that device A will send the information, right, and say, I want to send this information to device E, and device E's MAC address is so, 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 and so. You understand? So what this switch will do is that rather than broadcasting into B, C, D, E, it just knows that, oh, this device, this MAC address that A has provided for me belongs to E. So what it will do is that you just send it directly to E rather than sending to everybody. You get? So that is the difference between switches and hubs. So with this way, it reduce network congestion. So it reduce network congestion. I hope this is like understandable. So you can also research more about hubs and switches. That way you can learn a lot more about them. So let's go to the next one. We have routers. So routers are devices that connect multiple networks together. Routers route data packets between the network based on their destination addresses. Yes, let's go again. Routers are devices that connect multiple networks together. So let's say you have a cluster of network. You have a LAN here, a LAN here, a LAN here, LAN A, LAN B, LAN C. So to connect LAN A, LAN B, LAN C, you're going to make use of a router. So routers route data packets between networks based on their destination addresses. So routers use routing table. Please get research about routing table to determine the best path to send a data packet to its destination. So when devices are connected to a router, right, they are assigned destination addresses, right? So when a a particular device wants to send to another device, wants to send information to another device, it makes use of destination addresses, and there's something called routing table. So the routing table has destination address, and that can determine, okay, this destination address is for this particular system, and that is how it communicates with one another. That's how devices communicate with one another on a router. So let's go. We have firewall. Very important. This is one of the most important and basic way of protecting a network. Very important. So what are firewalls? Firewalls are devices that protect networks from unauthorized access. So let's say, for example, now your network, let's say in the classroom, there are 5 students. You connect the 5 students to a router, and the router helps them connect to the internet. You understand? So to be able to prevent what they call it, malicious things from coming into the network that you've created among the students, you set up a firewall. So what does a firewall do? Firewall inspect incoming and outgoing traffic and block traffic that are not authorized. Firewall can be used to protect malware attacks, protect sensitive information, and restrict access to certain websites and applications. So how does this work? Let's say you have the internet. You have 5 students connected to a router, and the router then connects the students to the internet. So what happens is that you set up a firewall, right? So this firewall prevents malicious information from coming from the internet to the network of that 5 students. Let's say, for example, now one of the students wants to access a malicious site. It can block the student from accessing that site. You understand? It block. Remember, there are some places, for example, in an organization now, if you want to visit a porn site, it will block you. Why? You don't have access to visit a porn site because a lot of porn sites are places where a lot of malwares are kept. There are even places where people download malicious movies. For example, you want to download movie but you don't want to pay for it, you don't want to pay for Netflix. There are some websites that when you use it, you know those ones that will be redirecting you to redirect you again for you to actually download a movie. You understand? So those things can actually have malwares. Those websites can actually have malwares on them. So what will the firewall do? The firewall will block you, the user, from accessing those websites. That's one of the importance of firewall. Another thing is that let's say an attacker, a malicious person decide that they found your network on the internet, they want to enter inside. The firewall can block the person from sending malicious stuff to the people under your network. Then also, let's say you are somebody wants to send a restricted information, a sensitive information outside your network to somebody else on the internet, but a firewall can block that information from going out. You understand? It can block the information from going out. So a firewall is very important. It's like one of the basic and the most important means of protecting network. Very, very important. One of the basic and the most important means of protecting a network. Then, okay, let's go to the next one. We have the network operating systems. So that's NOS. So these are operating systems that are designed to manage and support computer networks. NOCs provide features such as user authentication, file sharing, network security. NOCs are typically installed on servers. So NOCs are basically like operating systems that are designed to manage and support computer networks. Very important. So these are part of the security principles that you have to think about when you are setting up networks. Then the next one, we have network managing software. Very like it's good to have your network set up. It's good to set up a network, connect different users together, all this kind of stuff. But very importantly is that how can you manage these connections? How can you manage what is going on in the network? How can you troubleshoot when there's an issue that arises? You understand? How can you configure new network devices? Right. So this is where network management software comes in. So you set up your network and you think about how to manage your network. You understand how to configure new network devices, how to troubleshoot when there's an issue, how to track network informations, network performance, how to say, okay, my network is working fine. This is why the network stopped working before, and stuff like that. All these things very important. So network management software is very important. So we have some of them like Manage NG Operation Manager. We have Progress, WhatsApp Gold. So it depends. So these softwares, these network operating systems and the network management system are often made use of by network engineers. So network engineers are another part of cybersecurity. So if you're going to network engineering, these are the things that you need to know about. Again, these are the tools that will make use of to help enhance and like help you manage your networks, help prevent malicious guys from entering into the network, help to set up your network and even make this a lot easier for you. So these are the tools that network engineers usually make use of. So we have network protocols. This is to the peak. Really, this is the very, when I say understanding network protocols can help you understand cybersecurity a lot more. And we're going to dive deeper into this probably in our next class. We're going to talk a lot more about the different networking protocols and all of that. So we have network protocols are the rules and procedures that govern how devices communicate with each other over the network. So what are network protocols? They are rules and procedures that govern how communication works, right? How devices communicate with one another over the network. There are different types of network protocols, right? So let me just list a few that are here. We have TCP/IP. So that's is responsible for breaking down data into packets and routing packets to their destination and reassembling packets at the destination. So this one, TCP/IP protocol, It's basically used for transferring data, transferring packets. So from the person that wants to send it, that's the source to the destination back to source for reassembling and assembling packets of data. We have HTTP. So HTTP is used for web applications. You understand? So that thing that enables you to see the web pages. When you go to the internet, you want to see web pages. That thing that enables you to see web pages, that is called HTTP. Then we have the FTP, which is file transfer protocol. So that thing that allows you to be able to transfer file, transfer music, transfer documents from one person to another. You understand? That is called FTP rather. Then we have the SMTP. This one is for mails. This is a protocol that is used to send emails. So to be able to send emails from one email address to the other email address, there's a protocol called SMTP, which is very important to be sending emails. This we're going to dive deeper. I'm just bringing this here just for now, but we're going to dive deeper in our next class. We'll be talking about different protocols and the associated ports, networking ports. You understand? So there are different network ports that each protocol, you understand, that each protocol makes use of. Of course, they can be configured, but there are default ports that on a network, um, that particular service or that particular protocol usually makes use of it. Then now we're going to talk about how computer network works. So computer network works by connecting devices together so they can communicate and share resources. So you have 5 students in the classroom. You want these 5 students to be able to communicate, send information. Let's say you are doing a project, you understand? You want them to be able to send information. You want them to be able to print what they are doing. All that can be done by a computer network. The data is transmitted over a network by breaking it down into packets and sending them over the network one at a time. And the packets are reassembled at the destination. So let's break it down. Let's say for example now I'm on a network, or we are on a network, and then there is device A and there's device D. So device A wants to send a music file, right? A song, a very nice song, to device D. So how will it work? Device A sends this information. Let's say they are connected with a switch. Device A sends this music file to the switch, and the switch has the MAC address of device D. So what happens is that the data is broken down into packets. So all the information does not just send at once. They break it down into different packets. And each packet, what does each packet have? Each packet has the source address and the destination address. So the source address of device A and the destination address of device D, you get. So by the time it's transferring over a network or over the network, it doesn't have to be wondering who am I sending it to. You already know that it's going to device D. So each of the packets keep on transferring to device D, from device A to device D, from device A to device D. By the time all the packets now get to device D, then it will now assemble itself, because sometimes the packets might not transfer like in a chronological order. So it will now assemble itself in device D. Do you get? So that's how a computer network works. That's how people send information. You understand? So it breaks the information into packets. So that packet contains the source address and the destination address of whatever, of the person that is going to receive the information. And it will be going one by one, one by one, one by one. The fact that you don't notice that it's going one by one because it's very fast. For example, you want to send a PDF file to someone that is 2 MB now, you will not really feel that it's breaking it into packets, because all of a sudden sharp sharp everything has entered into your phone. You understand? But it's actually breaking it into packets. You get? So devices communicate with each other on a network using a variety of protocols. We talked about protocols before, right? So there are rules and procedures that govern how devices communicate with each other. So we're going to dive more deeper into protocols. Let me just read this explanation of how computer network works. Number one, a device on the network wants to communicate to another device on the network, and that's the network. But the device creates a data packet. Data packet contains source address, destination address, and the data that is being transmitted. A device sends data packet out of the network, out onto the network. So let's say device A now wants to communicate to device D. So device A will generate a packet. What is inside that packet that device A is generating is having the source address of device A, the destination address of device D, and the data that device A wants to send to device D. I hope I'm not losing you. So once the data packets are generated, device A will send the data packet to device D over the network. You understand? So the device sends the data packet out onto the network. The data packet travels through the network through the link and switches. About talk about links, right? So these are wired or wireless connections through the switches, endpoint, sorry, intermediate devices, right? So it sends the data packet over the networks, and the when the packet reaches the destination device reads the destination address. So it reads the destination address to confirm that okay, this is my destination address oh, and then it will now accept the packet. So whatever device A sent to device D has been accepted. So device D then processes the data packet, the data in the packet, and responds to device A. So when device D receives the information, it will look at it to assemble it, and then if it requires to give a response, it will now send a response back to device A. The same way, carrying the destination address of device A and the source address of device D and moving it over the network. I hope I've not lost you. I hope I've not lost you. Please, if you have questions, remember to send your questions in. You understand? If I've lost you, I can be explained it again. Hope this is clear enough. All right, so these are discussions that you should have, right? So what are the benefits of using computer networks? What are the benefits? We talked about it earlier. Can you remember what the benefits are? So what is the role of a router in a computer network? Think about it. What is a router? What is its role in the computer network? And how do devices communicate with each other on a network? I just been explaining it. You can go back, listen again, and then try to explain it amongst yourself. Now, if you have questions, please and please send your questions here. I want to be able to see your questions. Send your questions here so that we can be able to ask questions and understand, make sure that information is being passed across. Then assignment number one, differentiate between hub, switches, routers, and access points. So these are all these things that I just mentioned now are intermediate devices. They are the devices that connect the endpoints to the network. You understand? They are devices that connect the endpoints together. So you have to explain what is the difference between a hub. I know I talked about a hub and a switch, the difference between both of them, right? So we are going to also find the difference between a router and an endpoint. Then research and understand how VPN works. I talked about virtual and private networks, how these are very important because almost like in fact all corporate environments make use of VPN, especially when they are doing remote work. If a corporate environment, if an office environment wants to allow remote workers, VPN is paramount, like it's very important. And then number two is what are the common security threats and how can we common network security threats and how can it be mitigated. So we talked about computer network. So what do you think are the possible threats? Because we're doing cyber security, we're not just learning computer network, just learning computer network. I learn computer network because we know that it's very important and we can get threats. So what are the threats when it comes to computer network? And how can it be mitigated? So please drop your answers here. Right, thank you very much for the class. I hope this helped. I hope you were able to understand.